As I said, good afternoon, everyone. Thank you so much for joining us for a NOAA Library seminar. This is a repeat or a refresher on one we did last year. Today's is Community-Based Ocean Exploration Overview of the 2024 EV Nautilus Field Season. We are very excited to have Daniel Wagner back, the Ocean Exploration Trust Chief Scientist. And let's give a little background today. Dr. Daniel Wagner, serving as the chief scientist. He's conducted field work on deep sea ecosystems since 2006, and he's been participating in 27 multidisciplinary research expeditions that are exploring deep sea habitats throughout the Indo-Pacific, Atlantic, and Southern Oceans. Daniel used to work at NOAA as well in several different capacities and leading efforts aimed at collecting scientific information, supporting the management of the deep sea ecosystems in the US Atlantic, let me get that word right, and working with the NOAA Office of Ocean Exploration. But I'm going to let Daniel highlight more about himself and get this presentation rolling.
Wonderful. Thank you so much, Katie, for that introduction. And thanks to all of you for taking a little bit of time out of your day to learn about the exciting season that we have ahead of us. So as Katie mentioned, I am Daniel Wagner, Chief Scientist for the Ocean Exploration Trust. And today's presentations is really at a turning point and an inflection point of our 2024 field season. We just finished a couple of very successful expeditions where Nautilus was supporting work for Ocean Networks Canada. And over the next 5 months, Nautilus is going to be going across the Pacific, venturing from Hawaii over to American Samoa, Palau, and Guam. And there's going to be many opportunities for all of you to participate in the exciting discoveries. So yeah, the purpose is really to highlight what we're doing and how you can all get involved. Before I start, I do want to take a moment to acknowledge our generous sponsors. As I mentioned, we just did some work for Ocean Networks Canada and very thankful for their sponsorships. However, the majority of our expeditions this season, as well as in previous, are funded by NOAA's Office of Ocean Exploration and Research through the Ocean Exploration Cooperative Institute, a consortium of oceanographic institutions that includes us, the Ocean Exploration Trust, as well as University of Rhode Island, University of New Hampshire, Woods Hole Oceanographic Institution, and University of Southern Mississippi that all work together to advance the mission of NOAA Ocean Exploration. We're also very thankful to the support by the Bureau of Ocean Energy Management, building on the success of last year, where they supported a few days of ocean exploration. This year, we'll again have an expedition in collaboration with NOAA to American Samoa. And then last but certainly not least, a lot of our ocean-going programs are funded by the Office of Naval Research. So we have students and educators sailing on most, if not all, of our expeditions, and that support is provided by the Office of Naval Research. All right, so with that background out of the way, I just wanted to just to start us off, to kind of level set. I think in forums like this, there's a growing realization and really awareness that we live on a largely ocean planet, and that's also kind of percolating a lot into society. However, even in very specialized venues like this, I think there's a lack of awareness about how much of our planet is completely unexplored and unknown. So now most people realize that over 70% of our planet is the ocean, but very few people realize that most of that ocean is really deep, far away, and something that we know very little about. In fact, when we just look at how much of the ocean has been mapped with modern technologies, only about 1/4 of the global ocean has been mapped with modern technologies. So the other 3/4 of our world is still unmapped with modern technology. So all those areas there in black are areas where we don't even have good maps of what the seafloor looks like. And that's just thinking about maps. If we think about how much of the ocean has actually been explored visually, where either a diver has gone down or someone has gone in a submersible, or where we've deployed a camera or something that collects images. Now that is really a fraction of a percent, so much, much less than 1% where we actually have laid eyes on the bottom of the seafloor. And so the vast majority of our ocean and the vast majority of our planet are still in this deep, dark place where we know virtually nothing about. And that's really complicates a lot of our things that we try to do as stewards of the ocean or as stewards of our planet. You know, it's very difficult to manage a planet that you know very little about. And the information that we gather through these ocean exploration missions really has a lot of different applications. Now, if you don't know what the majority of your ocean looks like, it's very difficult to understand what the planet looks like, even just cycling of nutrients or how fundamental processes of carbon cycling or other large-scale processes work. It's really difficult to do that when you have that kind of scarcity of data. Climate modeling and understanding how tsunamis propagate or other aspects of these large-scale phenomena. They rely heavily on ocean exploration, and then also some very applied uses, managing our fisheries and managing our ecosystems. That also relies heavily on ocean exploration data. And last but certainly not least, there's obviously also direct links to human health. Currently, if we look at the rates of new drug discovery, those are 3 to 4 times higher when you compare marine products compared to terrestrial products. So just a tremendous reservoir of knowledge that's yet to be unlocked. And that's what really ocean exploration can do for all of us. And I really like to think that there's another really important side benefit of ocean exploration and just exploration in general, in that exploration of space and of the oceans alike is one of these few things that really unites us all, regardless of your age or background or political affiliations. It's one of these few things where, regardless if you're a 4-year-old kid or 80-year-old man, you will be fascinated, and you can all sit together and just be just captivated in the amazement of how much we still have to know. And this cannot be understated how important that is, particularly in times like we're going through today, where the divides between a lot of societal groups are getting bigger. Exploration is really one of these important things that can bring us all together and be a powerful force for good. So that really brings us to the mission for the organization that I work for, the Ocean Exploration Trust. We are U.S.-based nonprofit organization with the mission of basic exploration, so exploring poorly known parts of our ocean, seeking out new discoveries while pushing the boundaries of technology, education, and outreach. So the 3 pillars of our mission is really about scientific exploration. Second is using cutting edge technology. And third, then using the power of exploration and technology to really captivate audiences of all ages, all backgrounds, and really everyone. We own and operate the exploration vessel Nautilus, this wonderful platform, 68 meters, 224 feet. It's a state-of-the-art research vessel that's been with the Trust for the last 15 years, going around the world, doing expeditions and really trying to find new knowledge in these poorly known places. And it's a wonderful platform that has a whole bunch of technologies really specialized to go into these remote and poorly known areas. It has a suite of different multi-beam and sub-bottom profiling, so sonar systems. These are systems that are mounted on the hull of the ship. They produce a sound signal that then travels through the water column, then reflects off an object, either in the water column or the bottom, and comes back to the ship. And then you can calculate what the seafloor and what it looks like underneath you, create these wonderful 3-dimensional maps. And these maps are really powerful for many different things. They are used for a lot of different applications for models, but we also use them kind of in real time to kind of plan our expeditions and go to those places that are more interesting. So this is just give you a little bit of sense of, the background there is a typical map that you would get from satellite altimetry. So if you go into Google Earth and then start zooming in, you'll see that some of the bigger features, like these big underwater mountains, you'll actually be able to see. but as you zoom in more and more, it'll become highly pixelated. And that's really where the acoustic mapping system, these hall marking systems are incredibly powerful. They give you a much higher resolution of what the seafloor looks like, all that texture, all these valleys, peaks. And these are really the areas that are of interest to a whole different disciplines, whether you're a biologist, geologist, archaeologist, because a lot of the interesting phenomena happen on those areas where you find that interesting topography. So as I said, these maps are really kind of foundational, and it's something that we do pretty much on every one on our mission. In addition to our mapping systems, we also have a fleet of different remotely operated vehicles. So these are deep diving submersible that are uncrewed or unmanned, so nobody is going down with them. They are steered from the ship, and they have a whole suite of different sensors to really allow you to study environment, from getting really high resolution imagery of what the seafloor looks like, as well as a whole suite of different sensors that allow you to get environmental information about how deep we are, how cold it is, what the oxygen level is, and so forth. So yeah, these remotely operated vehicles are equipped with various high definition video cameras that allow you to get really nice images of the seafloor and really study different phenomena at different scales. If you want to do a broader survey, like the images of the top, and study biodiversity or whatever phenomena is at a broader scale, or if you're really interested at a more microscopic scale, even allow you to zoom in on smaller features that might be interested, or might be of interest to taxonomies that classify different life. Now, these remotely operated vehicles, they are operated from the ship, so there's a tether that connects these submersibles to the seafloor, and there's a group of pilots, engineers, and scientists that control the operation from aboard EV Nautilus. This is just a photograph showing when we are diving and we are in operation. So it's a group of about 12 or so folks that are controlling the whole operation, monitoring all the video screens, and they're coming up and monitoring all the different environmental sensors that are coming up from the vehicle. But another thing that makes this platform very unique is that white round structure there to the bottom of the ship, and that is basically, no matter where in the world we are, we bring our internet with us, and this is really remarkable. You can be thousands of miles from the closest city and still have really high bandwidth internet, and that allows us to transmit all the data that we collect, not just to the people that are on the ship, but really to anyone around the world that has an internet connection, can follow along and be a participant of our expeditions. And this is just a really wonderful tool for science, because it allows us to harness the intellectual capacity of not just the 50 people that are on board EV Nautilus, but potentially over 8 billion people on our planet. You can phone in a friend if you don't know the answer, and that's really the idea behind this, is that we might be exploring in an area where we don't know all the information with the people that we have on board, because we routinely come across things that no one has seen. And so this telepresence technology allows us to then engage the top scientists in whatever field they are from the comfort of their own home. But beyond just a science tool, it's a really wonderful tool for engagement and education and outreach. As I said, anyone with an internet connection can see exactly what we're doing. There's a whole several dozen cameras mounted around the ship that we stream continuously when we're out underway. And there's several cameras mounted on the ROVs that we also stream live, basically, when we're diving. And it's just a wonderful way to kind of see in real time these explorations unfold and be a participant of the excitement of discovery and exploration. So in terms of the priorities of our program, the Ocean Exploration Trust, I mentioned, we have been now in service for 15 years. We have, since the get-go, worked very closely with NOAA and other government entities. And so we align a lot of our work with the priorities of NOAA and other governments' priorities. A lot of the work that we do is really about basic exploration, basic mapping, so going to areas of the ocean where we have poor maps or poor data and getting a first-hand look. Another part of our mission is really about integrating emerging technologies. So I talked about the mapping and ROV systems and telepresence systems. That is something that we have that is our bread and butter. But over the last several years, and thanks to the partnership and collaboration with the Ocean Exploration Cooperative Institute, we're also integrating various other emerging technologies, so autonomous vehicles, uncrewed surface vehicles, landers, drones, a whole suite of different technologies that are really increasing the footprint of our exploration. The next two bullets there on the list are really important to our values and how we like to do our work. We realize that we go into a lot of places where very few people get to go, but that doesn't mean that these places are not important to people. And so really try to tailor our explorations to the needs of those places, and not just the science needs, but also the community needs. And so our expeditions are really co-designed and co-planned for stakeholders and communities from the places we get into. And that includes ensuring that the way we do our expeditions is culturally appropriate and locally relevant. And there's various different ways that we do to ensure that. Interdisciplinary and collaboration is a big part of our work. Our expeditions are really not driven by the individual interests of principal investigators, but really about the broader knowledge gaps of the community. We try to get as much information we do and then share it with the community at large. We really try to foster interdisciplinarity, because that's really where a lot of the big gains can be due, is when you have people with very big different skill set work together. And making our data publicly accessible is also something that we do. So I mentioned a lot of the data is accessible in real time. In addition to that, the data that is then quality controlled about after 2 months after most of our expeditions, that then gets sent into various different archives where anyone can then download it and use it for their research. In terms of the 2024 field season, it is one of our most far-reaching seasons in the 15-year history of the exploration vessel Nautilus. We just came back from a few weeks of work in Canada, so worked off British Columbia, and we will end our field season in Guam. So EV Nautilus, when it's all said and done, will have completed the equivalent of a complete sailing around the circumference of the world. So really incredible how much mileage, and just going to some extraordinary places across the Pacific Ocean. And I'll talk a little bit more about the exciting expeditions to come. Now, when you look at maps like this, it really a lot of times doesn't do justice in terms of what we're exploring. These maps really show the ocean as this mostly flat and uniform habitat. And so I like to show maps like this that really accentuate what the seafloor looks like. And I mentioned over the next 5 months, we'll be working in the Central and Western Pacific, and that is really one of the most exciting places for many disciplines, whether you're a geologist, whether you're an archaeologist, whether you're a biologist. This is where you have some really stunning underwater topography and features that are have a wide range of interest. So hopefully there's something for each and every one of you as we explore these places. In terms of our main drivers or main kind of themes, a lot of our explorations are going to areas where we think we're going to find interesting geology and biology. So a lot of our deep water explorations are looking for areas of high biodiversity. That figure on that photograph in the top left is one of my favorite photographs. That was taken about 2,500 meters, so over 8,000 feet. Last September in the northwestern Hawaiian Islands, the Papahānaumokuākea Marine National Monument, where you just see an incredible diversity and abundance of life. So that just highlights that most people, when they think about the deep sea, they think about these ocean deserts. But if you know where to look, there's a lot of life and a lot of interesting life. And just to give you also a sense of scale, those spiral shaped organisms there in the top left panel, those are corals that are about 5.5 meters in height, so about the size of an adult giraffe. So we're not just talking about tiny things, we're talking about really extraordinary diversity that can be found in the deep sea. We also, a lot of our expeditions are looking at areas of hydrothermal vent activity. The Western Pacific and other places we'll be exploring, like American Samoa, are places where we have active volcanoes and active materials from the center of the Earth really coming into the ocean, and that really creates fascinating habitats for a wide range of animals, areas where you typically find a higher productivity, but also find interesting chemistry and really remarkable geology. And then speaking of geology, that is another theme of a lot of our expeditions. The Pacific and the Central and Western Pacific, where we are going to be doing work, are places where we have some really old seafloor, so seafloor that was created over 100 million years ago and older. So that really provides another lens through which to interpret a lot of this data. And it's also important because some of our expeditions are where you have old and new seafloor in close proximity to one another, so they allow us to really get a sense of what time in the ocean and time on Earth will mean. In terms of the technologies we'll be using, so I already mentioned in terms of the bread and butter, how we do our explorations. The majority of our expeditions are this kind of model where we kind of map an area, then deploy our remotely operated vehicles, and then use our telepresence technology to engage scientists, engineers in the community at large. So this is really what we'll be continuing to do. But in addition to this technology, we'll also be deploying various other autonomous technologies this year. We'll have 2 back-to-back expeditions in American Samoa. We'll be deploying various underwater, surface, and lander vehicles. That really it's a really exciting development. In many of those our expeditions, we're deploying all of these technologies at the same time. And this basically then allows you to multiply the footprint of the areas that we can explore much more effectively. And the other thing about these technologies, they also expand the depth horizon of what we can explore. So the remotely operated vehicles that we have on Nautilus, we have different configurations, but we can either dive to 4,000 or to 6,000 meters, so 13,000 or 20,000 feet. The 2 vehicles that we have there on the bottom, so there's an autonomous vehicle Sentry that's able to dive to 6,000 meters, and then the Miskin carousel there, that's actually a lander by the University of Rhode Island, that is able to go to full ocean depth, and we're able to deploy that to go to some of the deepest areas of the world, and not just look at what's on the deepest seafloor, but then our sample through the water column as these instruments ascend and descend. In terms of how we can categorize our expeditions, an important thing for those that might be a little bit new to Nautilus and the Ocean Exploration Trust is that we have kind of 2 main mission types. So I alluded several times through our work with Ocean Networks Canada. That really fits into this first type. So those are expeditions that are funded for a very specific purpose. So we're either doing a very specific survey at a site, or we are changing a sensor or deploying a sensor. Now, these are expeditions where most of the kind of science planning is done up front and done by a small team. We still live stream this, and there's ways for folks to see what's happening, but it's mostly done for a very specific purpose. Now, the work that I'll be talking about that is happening over the next 5 months, all of our NOAA-funded work falls into the second mission type. Those are really funded with a much broader objective. They are funded to advance the goals of the broader ocean exploration community. So these are really ways where anyone can get involved in helping plan and execute these missions. These missions are not funded to serve the needs of just a single principal investigator, but really we want these to be helpful and applicable to everyone at large. In terms of the community planning process and how we plan our expeditions for these broader ocean exploration missions that I talked about, this is a process that typically starts about a year and a half ahead of our expeditions. For this year's expedition, so for the expeditions I'll be talking about shortly, we started the process really about a year and a half ago. In terms of what the priorities that we look at, obviously we would try to align those with our sponsors and those priorities of the federal government and the sponsoring institutions. We take a look at strategic plans and documents such as previous workshops that have been held where various stakeholders have priorities areas for exploration, such as that the screen shared there in the top left. But then, in addition to looking at areas that the community has already identified as priorities for exploration, we also circulate an open call for science input. We did that last September. This is in essence a Google form where anyone can submit priorities. You can identify areas within our operating areas where you think ROV survey or mapping survey would be most helpful, or a specific type of sample, of a biological or geological sample would help the community. So those are open calls. As I mentioned, we started that in September. And then in addition to that, we also have a whole suite of stakeholder meetings. We then meet with the representatives of the places where we're going, different government, academic, and private organizations. For our expeditions to American Samoa, we worked in close collaboration with the National Marine Sanctuary of American Samoa that helped us gather all the stakeholders in American Samoa to try to understand what the main priorities are there. So we had a really successful workshop there in March of this year that really gathered input. And then we collect all that input, so the input that we get from our call for science input, from meeting with stakeholders, from past workshops, and we distill those into a draft plan that we think is kind of our best guess of what could help the community at large. And those plans are then once again circulated to anyone that wants to, and kind of as a way to hopefully spark ideas, spark interest, and also provide more feedback about things that could be tweaked to help the community at large. And that last thing I really want to emphasize are scientists ashore, so not just the ones that sail on our expeditions, but really anyone that signs up for our program takes an active role in the planning and execution of our expedition. So really encourage any one of you that wants to get involved to do that, because we want to make our expeditions as applicable and as widely applicable as possible. So looking ahead over the next 5 months, so EV Nautilus is currently in Honolulu, and this Friday we'll be departing Honolulu to kick off 5 months of really extraordinary explorations that will go take Nautilus to the Pacific remote islands, the American Samoa, Palau, and Guam, exploring some wide diversity of habitats using different tools. So our first expedition starting here this Friday will take Nautilus about 1,300 nautical miles south of Honolulu to the area around Jarvis Island. So Jarvis Island is this really tiny island in the middle of the Pacific that has for a long time been recognized as being important for biodiversity. So explorers that have gone here for hundreds of years have recognized that the birds, the plants, as well as the coral reef fauna around this island are incredible diversity. And as a result, this area has been protected as part of the Pacific Remote Islands Marine National Monument. This is one of the largest marine protected areas in the world. However, we still know very little about it. And so this map here shows a little bit about what we know about the deep water ecosystems around this area. So the map there, all those gray areas are places where we have mapped the seafloor around this. And then every one of those dives is where we've actually deployed a vehicle or camera and have looked like what the seafloor looks like. So only a tiny fraction of this area has been mapped and explored. To put this into perspective, there's over 323,000 square kilometers, so that would make the exclusive economic zone around Jarvis bigger than 45 of the 50 US states. And yet we only know very, very little about this area. And so that's really what we're going out to set to do, is to fill those large knowledge gaps there in all those blue areas, or those areas where we haven't had data. And so the expedition is starting this Friday, and it will be a 19-day expedition with a lot of transit. So leaving Honolulu, actually we'll do one dive right off Honolulu to do a survey of a really interesting deep sea coral community, and then head down to the exclusive economic zone around Jarvis for some more dedicated ROV surveys around wide diversity of underwater mountains or seamounts and ridges. All those pink areas are areas that we're going to be exploring, and then have another large transit to go to American Samoa. In terms of the main themes of this expedition, so the majority of the time will be spent exploring underwater mountains and seamounts or ridges, and looking at areas where we think we're going to find interesting biology and geology, so areas of high biodiversity and areas where we also might be able to sample seafloor that we don't know how old it is, collect samples that we can use for dating. So that's really going to be the vast majority. 95% of the exploration is really those top three pictures, looking at the deep waters around it. However, this expedition also is going to have some interesting components. So as I mentioned, on the first day of the expedition, we'll be doing one survey off the east shore of Oahu, where there's some really extraordinary deep sea coral gardens. And so we'll be doing a survey there in collaboration with NOAA's Pacific Island Fisheries Science Center to understand the diversity, density, and extent of a precious coral bed. And then we'll also be doing one ROV dive of Jarvis Island that will start in deeper waters, but then we'll try to get as shallow as possible. And that is really to try to understand impacts that happened in Jarvis Island several years ago, where the reefs of Jarvis Island experienced one of the most devastating bleaching events recorded on Earth. And so NOAA's Reef Assessment and Monitoring Program had been monitoring that area for many decades. And that picture there in the bottom center shows some of that devastating bleaching. However, there hasn't really been any kind of follow-up surveys in the last 5 years, and so we don't really know how and to what extent these reefs have recovered. So we'll be supporting some, hopefully, shallow water work with our ROV, and also we'll be doing some shallow water surveys with drones and a snorkeling team to understand, if and when these reefs have recovered. And then last but certainly not least, also in collaboration with the NOAA Pacific Island Fisheries Science Center and with the NOAA Cetacean Research Program, we'll be deploying an acoustic receiver en route to the expedition ending port in Tutuila, American Samoa. So we'll be deploying this array of hydrophones basically off Tutuila to get some data for monitoring whales. So the waters around American and Samoa are known as a hotspot. It's an important marine area for marine mammals. However, there's very little data, with the exception of some opportunistic sightings from vessels, and the sensors we'll deploy there will try to fill that knowledge gap. So very exciting expedition that will kick us off and will be really the start of many others to come. So after our work in Jarvis, we'll then have 2 dedicated expeditions to American Samoa, also an extraordinary area for those of you who might have not been there. This is the only territory in the United States that is in the southern hemisphere, and it's also extraordinary biodiversity. When you look on land, on the reefs and the shallow waters, it's been known for many years. That's a really extraordinary area. But much like Jarvis, when you start thinking about the deep waters around American Samoa, we know very little about. Again, a very similar map to what I showed you. Areas in gray are where we have mapping data, and those dots are all where a dive has been conducted by different programs, including ours, but also the Oceanus Explorer and the Hawaii Underwater Research Laboratory. But the vast majority of this area, again, is completely unexplored. And so we'll have two back-to-back expeditions. One is a multi-vehicle exploration expedition. We'll be deploying 3 different technologies from partner institutions of the NOAA Ocean Exploration Cooperative Institute. That includes that red vehicle there in the top left, uncrewed surface vehicle DRIX, owned and operated by the University of New Hampshire. This is a wonderful platform that really kind of serves as a second ship, if you will. It has its own mapping sonars, both for water column as well as seafloor mapping. And it's a wonderful platform that will work in collaboration with the other vehicle there shown in the top center. That's autonomous underwater vehicle Mesobot by Woods Hole Oceanographic Institution. This is an autonomous vehicle that was really designed specifically to look at the midwater and the interesting life that we find there. It's capable to dive to 1,000 meters and collect high-resolution images as well as environmental data and eDNA data of all the interesting fauna that lives in the midwater. And that will be also paired with the third vehicle that I already mentioned previously, that lander top right. That is the Deep Autonomous Profiler, designed and owned by University of Rhode Island, Chris Roman's lab. So this is a piece of equipment that was designed around a nesting bottle carousel. But in addition to kind of your standard CTD and water sampling, it also includes several other things, including video cameras, passive acoustics, to get more information. And so over this 18-day expedition in August, a lot of that is focused around seamounts. For those who know the ocean and know the deep sea, you might have heard that seamounts refer to them as the hotspots of biodiversity or the rainforests of the deep sea. These are known as some of the most biodiverse and productive ecosystems. There's been studies going back several decades, really documenting that on the seamounts themselves, you find much higher abundances and higher diversity than in the surrounding flat seafloor. However, we still don't know a lot about how they compare to different environments. And the water column environments above the seamounts is also something that is greatly understudied. This is an area that often fishermen know this, that seamounts typically aggregate a lot of fishery resources above them, but still very little data, quantitative data, with the exception of a few very good case studies that have been studied in detail. So this 18-day expedition is really going to go explore in detail a variety of different seamounts around American Samoa and understand how they are different to the surrounding deep water abyssal plains. Following that, in September, we have a 24-day expedition that will also have a multi-vehicle component. So it will include both our remotely operated vehicle as well as an autonomous underwater vehicle, Sentry by Woods Hole Oceanographic Institution. So we'll be using both of these robots in tandem to explore a variety of habitats around American Samoa, all those pink areas. So a wide diversity of different habitat features that we'll be exploring during these 24 days at sea. A lot of the explorations are going to Wailuulu Seamount. So that is a seamount that is active. So it's an underwater volcano that sits directly above the Samoan hotspot. So the hotspot that is responsible for creating all the volcanic islands in American Samoa, as well as in the independent state of Samoa to the west. And so it's a really extraordinary site. And we'll be going there for a wide variety of objectives, including just understanding the basic diversity there. Wailuulu has a distinction in that this area has been mapped repeatedly for some time. And so we kind of get a sense of how these ecosystems change over time. One of my favorite stats is that these different mapping surveys that mapped the seamount over different time found that parts of the seamounts had grown by nearly 300 meters, so over 1,000 feet over the stretch of just 4 years. So a really, really dynamic seafloor area where new seafloor is being created. So a lot of work will be focusing on that. Also, we'll be working with different teams to develop new search algorithms for detecting plumes. And so that will be work that will be deployed off Sentry. A couple more components of this expedition. American Samoa is also the setting of one of the most significant losses in aviation history. So in 1938, a pretty significant seaplane went down that was on its route from Hawaii to New Zealand, and that seaplane has not yet been found. And so we'll be doing some searches to try to locate this really historically significant underwater cultural heritage site. And last but certainly not least, this expedition will also be targeting some of the abyssal habitats, so the majority of the seafloor around American Samoa, and in fact around all of our territories, is this flat area where we know virtually nothing about. So it's I'll show you those previous mapped in terms of areas that have been mapped or where we dive. When you look at those deep flat areas, virtually nothing is known about. So we'll be doing some surveys to try to understand what the seafloor looks like on these abyssal depths. Following our work in American Samoa, we'll then have a couple of expeditions focused in Palau. And Palau, for those who are underwater enthusiasts, you might have heard this referred to as one of the 7 wonders underwater world. If you have not gone, I'd really encourage you to pack your bags and pack your snorkels and scuba dive, because this is really one of the most extraordinary places on Earth in terms of the diversity and productivity of coral reef habitats and marine habitats. And it's been studied for many decades, well known. But just like I talked about Jarvis and American Samoa, if we look at the deep water habitats, very little to nothing has been known. So we'll have 2 back-to-back expeditions to really try to fill those enormous gaps. We're still very early in the planning stages, and have a suite of different areas that were identified by the community in all those pink areas for field surveys. So we're currently going through this process of narrowing down what areas to survey during these 2 back-to-back expeditions. And then last but not least, to kind of close us out for the year, we'll have 1 expedition to basically bring the ship from Palau to Guam for the overwintering period. That will deploy a whole suite of other autonomous vehicles, wave gliders, surface gliders, and a whole suite of different work. This will be done in collaboration with Scripps Institution of Oceanography and the Office of Naval Research. And the basic scientific question is really trying to get data in and around islands. So this is the island mass effect has been known for a while, that a lot of these islands have really big impacts on the oceanography around them that extends for a long time, but also little data. So we'll be doing some dedicated surveys around both Palau and Guam, deploying all these different technologies to get oceanographic data. So with that, I don't want to just spend the last bit of this webinar just kind of as a call for action about how you might get involved in our expeditions. So that question there, who can participate? And I hope that if you get one thing about this webinar that you get out of it, is that the answer is really everyone. And all you need to know is our website, nautiluslive.org, there on screen. This is a gateway for all kinds of really exciting pieces of information, a gateway for how you can participate and get involved. This is a screenshot taking several couple weeks ago when we did work off Canada. If you go to our website right now, it looks a little bit different, but when we're out at sea exploring, this is what our landing page would look like. There's a link to our live video different panels that show, where in the world we are and what we're doing. There's also actually a panel there on the bottom of the screen that can actually ask a question if you're just curious. You can type that in, and we have educators on board that monitor that feed and respond to those questions as they come in. You can toggle between different cameras. So now, for those of you who kind of ad hoc interested to kind of participate here and there as your time allows, now the Nautilus Live is really a wonderful portal to kind of just get a feel for what these expeditions are. So in addition to seeing the video of what we're doing, you also get the audio, so you'll hear the discussion of the scientists, pilots when these expeditions come. So it's a wonderful way to just kind of listen in and get your toes wet for ocean exploration. Now, there's a whole suite of education and outreach programs. I mentioned this is the third pillar of our mission, and this is something that we have an incredibly talented, hardworking team that does an extraordinary work to ensure that the science we do is not just for scientists, but is science to really connect with communities and society at large. Nautilus Live / Education is it's a wonderful gateway for a whole bunch of different resources that can be used. So there's a whole bunch of educational resources, highlight videos, curricula, classroom models, a whole bunch of things that, for those of you who might be educators, there's also a link there for each and every one of you to request on a first come, first service or live ship to shore interactions. So these are 30-minute to 1-hour conversations where you can connect with personnel on the ship and ask them anything you might be interested in about what life is at sea, what the expedition is like. Again, a great way to connect your audiences with what we do. So if you have a staff meeting or any place where you have a captive audience and you want to give them some exposure to deep sea explorations, when we're exploring 24 hours a day in all time zones, you can request these ship-to-shore interactions. And then we also have various at-sea programs. Now, as I mentioned, through the generous support from the Office of Naval Research, we do provide opportunities for students and educators to come out at sea. These are paid positions that are given out in a competitive application process that typically opens up in about November, December each year. We have an open call for these internships and fellowships, and then whether you are a student that wants to come out at sea and can apply for our science and engineering internships, or you are a professional educators and want to come sail on Nautilus and help us be part of our storytelling team, these are great opportunities for folks to experience life at sea. Also active on 6 different channels of social media. And last but not least, in this year, because we're going to be in some more remote locations where COVID is a little bit less of a concern, we'll also be able to provide some limited ship tours to bring communities and community representatives really from these places on board Nautilus and interact with the technology and the team members on board. Now, that's just for the educators and students. For those who have a vested science interest to be active participants of our expeditions, we have our Scientist Ashore program. So anyone can sign up. All that we just ask is that you have some expertise that is relevant to what we're doing on that expedition. So there's a form that you can fill out on our website. And basically, you'll become part of our Scientists Ashore. We'll add you to our listservs, and you'll start getting information about the planning of these expeditions ahead. While these expeditions are at sea, you'll start getting daily updates about what's going on and our plans for the next day or so that you can also time your schedule to be online at the times of most interest. And one really important thing is once you sign up for our Scientists Ashore, you'll also get access to our OET Science portal. And that basically gives you access to not just that one video screen that you can see on our website, but a whole bunch of other screens, all of the real-time data, and also a chat that allows you to communicate directly with the scientists on board and really be part of the science team. And before I close out here, I just wanted to also a couple other ways that people can get involved. All of our data, with the exception of a few cases where it's protected by regulations, is made publicly accessible pretty quickly after our expeditions. All these various repositories where you can access the data, they're all linked on our website, but that includes the videos from our dives, the highlight images from our dives, the mapping data from our operations, the biological or geological samples. These all get places where anyone can request these and then start. Many of these places can directly download the data there. For those places where we're talking about physical samples, both the Harvard University Museum of Comparative Zoology, as well as the Marine Geological Samples Lab at URI. These provide ways for you to request samples on loan or provide ways for you to access their laboratories and then study these samples there. So there's a lot of discoveries yet to be made from previous data that is archived there. So for those of you who might be graduate students or still looking for research programs, there's really a treasure chest of discoveries yet to be made if you just look back at the 15 years of data that we've collected with Nautilus. So many ways to get involved. If you get one thing out of it, please encourage you to look at our website and the many different archive resources, whether you're an educator, scientist, or just ocean enthusiast. I hope you find something that is of interest to you. For those who are kind of active scientists or resource managers in the places we are, we encourage you to check out our expedition plans and sign up as scientists ashore. What that will trigger is you'll start getting alerts about the planning and execution of these expeditions. So there's, for you to become part of our greater science team. And then also, as I mentioned, there's a couple other ways, request ship-to-shore interactions if you want to expose your audiences to what we do on Nautilus, or just follow us on social media. And with that, I know I'm kind of short on time, but I did want to just thank all of you and also thank the NOAA Ocean Central Library for hosting us. If I have time, I'd be happy to address a couple of questions. If not, my email address is there too, and happy to address those over email as well. So thank you so much. Really appreciate everybody joining us for this hour.
Thank you so much, Daniel. Just because I see that your face was covering your email, I'm just gonna double check. It's daniel@oet.org.
That's correct. Yes.
Okay, I'll make sure that gets in the chat for everyone. And now is the time for Q&A. So if anyone has any questions for Daniel, please put those in the question panel. I don't see any yet, so I'll give everyone a moment to see if they do have questions, but we are close to time. So if we don't get any questions, we can end early or end a few minutes early. We only have a few minutes. But Daniel, thank you so much. This was, again, a super comprehensive presentation exploring where you guys are going to be, which seems like a lot of places. And I did put into the chat as well NOAA's ocean exploration page about the 2024 field season and all of that information. And it links out as well to the Nautilus Live site. Showing off that kind of telepresence enabled program that Daniel was talking about. So I'm still not seeing any questions, but I am going to kind of turn it back to Daniel to see if he has anything he would like to add before we close.
Yeah, thank you so much, Katie. Not much more to add, only to thank once again all of you for taking time out of your busy day to learn a little bit about what we're doing and how you can get involved. One thing maybe to add is that we are one platform, and there's other platforms that do similar work. So NOAA Ship Oceanus Explorer, NOAA's flagship for ocean exploration, has a very similar model. for all of you to get involved in deep sea exploration. So that's another great resource. Just once again, thanking all of our sponsors, and in particular NOAA's Office of Ocean Exploration and Research through the Ocean Exploration Cooperative Institute, really allowing us to go to all these exciting places and then allowing us to bring all of you with us through telepresence technology. So thank you so much.